be interested in using some arrow diagrams to visualize the relation that you have here. So you have two sets, set A and set B, and you define a relation between A and B this way. You say that, hey, X and Y is in that relation if and only if the division between Y and X is actually an integer. So we can list all of the elements that we have here. We can take the Cartesian product, which includes all possible outcomes, and take R, which is a subset of the Cartesian product. But R follows this specific definition. So let us check to see if 2 and 6 is a member of R or not. 6 divided by 2 is 3, which is an integer. So 2 and 6 is in R, because 6 divided by 2 is an integer. So this set, R, can be written as, well, using its members, 2 and 6. What about 2 and 8? Of course, 2 and 8 is a member of R, because 8 divided by 2 is 4, is an integer, following the definition. So 2 and 8. What about 2 and 10? Yes, 2 and 10 is also a member of this relation. 10 divided by 2 is 5, an integer. So 2 and 10. What about 3 and 6? Yes, we don't have any issue with 3 and 6. 6 divided by 3 is 2, which is an integer. So let's go to the next line, 3 and 6. What about 3 and 8? Well, 3 and 8 is not a member of R. Why? 8 divided by 3 is not an integer. It's just a fraction that cannot be simplified. What about 10 and 3? So obviously 10 and 3 is not a member of R. Again, 10 divided by 3 is not an integer. What about 4 and 6? 4 and 6 is not in this relation, since 6 divided by 4 is not an integer. 3/2 is just a fraction that cannot be simplified. What about 4 and 8? Yes, obviously with the same logic, 8 divided by 4 is 2, which is an integer. How about 4 and 10? 10 divided by 4 is not an integer. So our relation has only 1, 2, 3, 4, and 5 members. The cardinality of this new set, or the size of this new set, is 5. Note that the cardinality of your original set for the Cartesian product between A and B is actually 9, and R as a subset of the Cartesian product between A and B has fewer members than the original set. Now we can use some arrow diagrams to connect these together using relation R. Set A has 2, 3, and 4. This is your domain. The codomain are members of set B, 6, 8, and 10. Codomain. We can use some nice colored papers here. So 2 is related to 6, 2 is related to 8, 2 is related to 10, to 6, to 8, to 10. What about 3? 3 is only connected to 6. So let me use a different color here. 3 is connected to 6. Also, you have 4, which is connected to 8. And that's it. This arrow diagram represents this relation R, which is defined for you here. Note that you can write X is related to Y if and only if Y divided by X is an integer, belongs to Z. That's the representation for integer, bolded letter Z.